Hello.
Hi.
How are you?
How are you?
Good.
I'm
Guess
not
I'm the only
entirely
one here
sure.
right now.
I'm sorry?
I guess I'm the only one here right now.
Yeah. Um, I think only 9 people signed up, so I'm
Oh,
not, but I'm not entirely sure how many people will show up. But if not, I don't really mind going one-on-one either. So
yeah. Well, I mean, like 68 people were like watching one of the sessions earlier, and only about 2 people were actually talking. So,
oh really?
yeah.
Oh. Um, well, I mean, so what's your background? So that I can kind of gauge like what level to go with.
Well, I don't really have much programming experience. I have about 1 semester of like HTML and CSS.
Okay, yeah, no, that's totally fine.
But
Um,
that's it. It was just a 1 semester class, and that was it.
are you in college right now?
No, I'm actually a junior.
Oh, in high school.
Yeah,
Oh, okay, you're in the semester system in high school.
yeah.
Okay, I see. Okay. Um, sorry, have a semester system in high school when I went.
Oh, really?
Yeah, and it was just like an entire year type of thing. In that case, well, let's just actually just go ahead and start. Do you know did you get the link for the Google Collab Drive?
No, I didn't.
Okay, let me actually just paste that into the chat. Okay. So it'll bring you to
It popped up.
okay, great. Now what you're gonna do is you're actually gonna go into go click on file and then click um,
Save.
copy and drive. Yeah, or actually
Uh,
copy a copy and drive and I'll create a new copy for you.
oh, okay.
Yeah.
All right. All right.
Okay.
Copied.
What made you interested in computer vision? So out of curiosity.
Well, my mom wants me to get into cybersecurity because it's a really high-paying job at the moment, and right now I'm just trying to figure out whether programming is right for me. So I wanted to, and then I got a notification saying that since I was in IT for my classes, that they gave me this link because I'm in K-12. So
Oh, okay. Yeah, I mean, this is, um, we're just gonna go over Python today. So, so computer vision is a type of technique that, it's a type of technique to analyze and process natural images. So the example that I give the most is, say when if you take a picture and you want to filter it through some type of filter on Instagram or something like that, that's part of image processing. And it's also computer vision as well. If you have Zoom, if you're on Zoom video call and you have like a mask over your face, that type of photo editing is also computer vision, to be able to identify and recognize different facial structures and be able to overlay different filters on top. So that's part of what computer vision is. And so the first thing that I want you to do is actually go and run the first cell. So I think you can, if you're on a Windows, it's Control Enter. If you're on a Mac, it's Command Enter.
I'm on Windows 10.
Okay, you can either press the play button, or you can do Control Enter on the first cell under Task 1.
Press the play button. I'm not seeing that.
Oh, okay. Let me see if I can. Let me actually.
I see it now.
Okay. Okay, so you can either click on this one, or you can just do Control Enter, and then just upload any image file that you want to play around with. If you don't have one ready, or if it's too big of an image, then you can always download a boring gum picture that I have on my server.
Okay. Let me just. One second.
No worries. Okay.
Can't seem to get it to want to work.
Oh. Did you upload it?
Yeah, I uploaded it.
Okay. Okay. That should be fine. Then go, if you did upload it, then just go to the next one and just click run as well.
Okay.
Okay. So, and then so if you know the name of your file, you can just put it in here. So
What am I clicking?
You're editing this portion in the third code box, the name of your file, just this portion. Where it says bear.png, you would just name it to your file name.
Oh, okay. Okay, I got it to work.
Nice. Okay. And you ran it?
I ran it and it showed up as different colors.
Okay, yeah, that's because the RGB, so in a color image, it's you have 3 channels, so it's more of a it's a 2x2 image, 2x2 meaning or like n by n image, and you have 3 channels, so it's an n by n by 3. So the depth is 3 because you have the RGB channels, and in the C2 module, it actually flips the channels around, so it becomes BGR. So it's if you actually run this, it says no OpenCV reads in images as BGR, not RGB. If you would like to change the channels, run image equals image 0. You're just flipping the last 3 channels. And so if you just copy the latter portion after the colon into the third line right after,
Into the one that says image?
mm-hmm.
Or the one? Okay.
So you paste it in there.
All right. I think I must have done the wrong one because it says it's an invalid syntax.
Do you have the image? Okay.
I'm just messing it up a lot.
No, don't worry about it. Okay, let me actually run this with you. Sorry.
No, you're good.
This is the only screenshot I have on my desktop right now. But let's see. Okay, so if I comment this line out, meaning it's not going to run it. So let me actually just delete it. So what you see is the inversion of colors because you have the blue channel in the front and not the red channel. So what you can do is you can go into the line here and then type. Python is space sensitive, so you don't want to skip a space. So you can go image img equals you're reassigning the variable. Go img bracket and then ellipses and then bracket 2 1 0, and you're flipping the last 3 channels.
Okay, let me try that.
Okay.
I'm trying to be able to read this, but for some reason it doesn't let the screen go any bigger. So.
Oh, read mine.
Yeah, I'm trying to read what yours says, but it's hard to tell because the screen gets too small for this for some reason.
You still can't see it?
Okay, that says image. Okay, I got the wrong thing.
Okay, I'll try to get bigger.
It didn't load the image, dang it.
No worries. It's okay, take your time.
Is that an equal sign or a dash?
Where? And that it's an equal
For the
sign.
image something image. It's that one that you put right there where your cursor is. The
This one's
thing
an
where
equal
you're.
sign.
Okay, now it's showing up. 210. Yeah, I don't know what's going on. It's not working.
Oh, okay. Well, it's okay. We'll just delete that line and we can just move on.
Okay.
Okay. So.
Because all that popped up was parentheses 800, 1200, and 3.
Yeah, so those are the dimensions of your image. So your image has 800 pixels wide, and it has
1200 tall.
Huh?
1200 tall.
Yeah. So actually, 1200 is the width, and then the height is the 800, and it has 3 channels.
Oh, okay.
So yeah, those basically mean dimensions. And so moving on to more image processing methods, and basically the background functions that are running when you blur an image on an app, or if you want to turn something black and white. You can program it directly through Python to do these different types of image processing methods. The first one that we're going to look at is image smoothing, and so that's blurring of the images. And so go ahead and for the averaging kernel.
Okay, that worked.
Okay, cool. All right, so it's blurry. Not very exciting, but also there's also Gaussian.
And it's the correct colors too this time.
Oh, okay, perfect. I don't know why it didn't show up in the other one, but yeah.
Maybe I accidentally deleted something that I needed. I don't know.
Oh, it's okay. No worries. So if you go on to the next one, this is a similar blurring function, except this one's a Gaussian filtering. And so Gaussian filtering is a different type of kernel, but we can I go more into details later. And another tool or another function is image threshold, and it's the way that it works is if a pixel value is greater than a certain threshold value, it's assigned a 1 or a white or something or otherwise it's assigned 0 or black. So basically it thresholds the image and turns into a black and white photo. And so the first thing we have to do is actually we have to load this image in as a grayscale. And so if you click on run, it should turn your image into grayscale.
Oh, wow. That looks horrible.
What's your picture of?
Well, it's actually my profile picture on Discord, and it's just, I looked up Nova space on just Google, and I saved it, and it's basically just turned the whole image to black with little spots of white. Yeah.
Oh, okay.
So maybe there's just a lot of dark elements in there.
Yeah. Is it okay? That's interesting. That might be a bit difficult for the next step, which well, actually, hold on. Change your threshold value to.
That's the image. It's a lot of purple and dark blue.
Oh, okay. Actually, then can you actually change this to change the threshold value to 50?
Okay.
Just lowering. So then, if you have a lower threshold value, it means less brighter colors is the cutoff line, and so it should have more white.
Yeah, it pretty much did the opposite.
Oh, okay. Then let's try 100.
Okay. It's all about trialing and erroring.
Yeah.
Yeah, that looks all right.
All right. Okay, that's
It's a funky image.
yeah. I bet there's a lot of dots, huh?
Yeah.
Or is there any cohesiveness to that image? Or is there a blob anywhere?
It's basically all a blob.
Okay, that's perfect. Okay, that's gonna work for the next example then.
Okay.
So candy edge detection is an algorithm that detects edges, and what have you taken calculus yet?
No.
Okay. You're in Texas.
I don't know. Yeah, I don't know if it's a requirement. I don't know about that, but if it is, I'll take it. But if it's not, then I'm probably not going to take it.
Yeah, it's no fun, but it is an interesting topic just because calculus was actually, sorry, I'm going to go off on a little tangent, but calculus was actually invented to solve physics questions. And so if you want to take the derivative of something, you are basically trying to solve for the change in something. So then if you want to change in distance over time or velocity over time, those types of questions we answer using calculus. So another useful usage of calculus is in this algorithm is candy edge detection that basically calculates the intensity gradient. So say like if I put my hands like here, then the color intensity with between my wall color and my hand color is not too high, but if I place it next to my, sorry, I'm trying to, okay, next to my bookshelf, you see how the black contrasts very greatly with the with my hand?
Yeah.
So this would have a higher intensity gradient because the change in the intensities is much higher than the change in intensities here. And so basically
how like a blue or green screen works.
Oh, I didn't know that actually. Okay, so it's a high intensity gradient difference then in green screen, blue screen?
Yeah, if the colors are pretty close to the green, especially the shading, then it'll cut off that part. So if you have like a green screen with a little background behind you, then sometimes you'll see people's faces gone or something. Like that.
Yeah, I've seen that. Yeah, yeah. I kind of like that. I think green picks up green colors. Um, in this case, we're calculating the differences between the colors. But yeah, I mean, probably uses the same, like, similar algorithm. And so if the contrast is greater than a certain value, then it's considered an edge. If it's not considered an edge, we just get rid of it. And so so let's see if these preset parameters work for you, but can you go ahead and run the candy edge detection?
Yeah, it kind of works.
Okay.
You can't tell that it's the same picture anymore, though.
Did it form edges around the blobs?
Yeah, it did. It's very complicated, though. Like, you see like the different rings on the front of the image. That's really the only edge that it picks up. Everything else is just the edges of the different stars in the background.
Oh, okay. Interesting. I wonder if we could play around with the numbers a little bit to try and see.
No, I put it in the soft cam. The medium soft cam. Use the medium soft cam.
Try like 20 and 30 instead of 100 and 200.
Okay.
The one with the ribbing inside. Oh, soft cam. That's a skillet.
Oh no. It turned into a bunch of carpet-looking texture.
Yeah, it's because we lower the thresholds, and so it's like, so everything kind of can be included in the edge.
That's weird.
Yeah, I know. It's maybe like 50 and 200.
I think 50 and 100 makes it look a little bit better.
That's perfect. Let's go with that one. You know, like another way that, like, if you, do you have any social media or photo editing platforms?
I do, but they're more of a private thing.
Oh yeah, no worries. But basically, that's.
I guess I could use the Discord because that one's the only one that I use of social media that's basically school related.
Oh no, it was just like an example. Like if you were to kind of modify an image on social media, you're basically running these types of algorithms in the back. And so basically, you're doing the back end stuff right now instead of what you see on like an app. So yeah, so those are we've covered so far: blurring, thresholding, and edge detection. So then the next one we're going to look at is morphological transformations, which is a mouthful, but basically it's some simple method to change the shape of the of an object in an image. So in your case, it would be if you wanted to get rid of all the stars in the background, then you would use morphological transformations to get rid of the stars in the background. Just type of like image processing techniques. So
I ran it and it turned into a bunch of ones.
Oh really? Oh,
yeah,
so that one. Yeah. So that's a structuring element, and so that's basically anything when we do these morphological transformations, it's if the structuring element, in this case, it's a 30 by 30 box. If it doesn't cover the pixels, then it will erase it. If it does cover it, it'll erase it during the erosion step. But if it does cover the pixels, then it will dilate it in a dilation step. So if you actually can go ahead and maybe do 3 by 3 instead of 30 by 30.
Okay.
Now you get a 3 by 3 matrix. That's much easier to see. And then in the next, I'll change it by 2, 2 for the structuring element. Oops. And then try running that. I don't know if you see a huge difference between the dilation and the erosion.
It's not a big difference. There's just some things that's like one picks up more light than the other.
Oh, okay. Can you try changing the first structuring element to 5 by 5? Structuring element to 5 by 5.
Okay.
And then run that again.
That made it like a lot brighter.
Okay, cool. Yeah, so that's like one way to expand whatever is already bright, or to shrink. And your mom's calling you.
Yeah.
Okay. Okay, no worries. Okay.
Sorry.
No worries.
My mom was making me go get the garbage cans out to the street, so.
No worries. What part of Texas are you from?
I'm actually in Melissa, and the reason why this is right here is because we're in the process of moving. My mom doesn't like showing our messy background.
Aw. I'm glad you got that off for 50% off.
Yeah, your custom framing order.
Oh, is that a photo? Is that my photo?
Yeah, it's a black and white photo of the forest.
Wow. Did you take it?
Not me, anyway. The artist is Adams Ainsel. I don't really know who that is. Or Ainsel Adams, but it's of the Redwoods Founders Grove, it says.
Yeah, I was just gonna say it looks like the redwoods. Yeah, but I thought that since you live in Texas, I didn't think you would. But
Well, my parents, they basically grew up in California, so.
oh,
They grew up
awesome.
in California. The first 2 or 3 years I was born, I was living in Maui, so it was before I could remember. And but now we lived here in Texas, and we've lived here for about 12, 13 years now.
Wow. So
And
you
we're
were
gonna
born
be,
in Hawaii?
yeah, I was born
Maui?
in Hawaii, and me and my brothers all have middle names, but they're so long. They're long Hawaiian names, so I can't remember my other brothers, but my full name, since I got it's funny, I got a middle name from one of my mom's crushes in high school, and then I have my Hawaiian middle name, plus she just got her last name added to my middle name. So I have 3 names in total, and it all spells out as Parker Kaali'i Okahale Reese Vaughn Swicegood.
Wow, that's a code name. And like
Yeah,
that's so long.
try writing that down for information on like a I don't know.
I
That
can't
would take
remember.
forever. Yeah, it takes
Seriously.
forever. My
Wow.
driver's license, it's too long.
I mean, your Hawaiian name's super long.
Yeah, it's Keali'i Okahale, and it means chief of the house.
Oh, that's
And,
awesome.
and it's because of, I think, one of my grandfathers, I guess, like, his name was Harry, I think, and I guess that's how it's said in Hawaiian, is chief of the house.
That's really cool. I really like that.
Thank you.
My entire name is 7 letters compared to yours.
Oh, wow.
I know.
I don't know how many letters mine is, but I'm not going to count.
Okay, so moving on to image filtering.
Okay.
So okay, so image filtering is well, we just did an example of it with image smoothing, but it's when you have a 2D kernel, like or a box right here. It says for this one.
Yeah.
So this was an X pattern, because if you envision the white as 1 and 0 as black, then you have a white X. And so when you run this through the 2D image, what you do is you multiply each element by each element, and then you sum it all up. So it's 1 times 1, 1 times 0 times 0, and then 0 times 1, and then so on. So then when you multiply all these element-wise, and you add everything up, it becomes a 4. So you can see that if you do a 1 times 1, if the ones overlap, it'll give you a 1. If it overlaps with a 0, then it'll always give a 0. So it's a way to detect patterns in an image. And this is an important aspect of a convolutional neural network, which is, have you heard of deep learning before or machine learning?
Yeah, I think so.
Yeah, so
Isn't that just basically AI?
yeah. That is AI. But it's so
That was
it's
really that time.
okay. I heard Aaron. I wasn't quite
We
sure.
all have ers in our.
Oh, okay.
So I'm Parker. Next one's Tanner. Next one's Hunter.
Oh.
So it gets really confusing to the point where sometimes she goes, Hunter, I be Tanner, I be Parker.
That's really cute. Okay, so if we this is called a convolution, and so the areas where it overlaps, you have a high number or a high score, and so this is an example of a Gaussian kernel, and a Gaussian kernel is based on a Gaussian distribution that it looks like a. Have you ever heard of a normal distribution?
No.
Okay. Wait, let me see if. Okay. Okay. So. It's okay. I mean, it's not a huge concept. So, I see, Kazim in the people chat box. If you want to join, sorry. Hi.
Oh, there we are.
Do you want to share your video and audio as well?
Earlier, it said that there were 3 out of 9 people in here, but then I checked the amount of people and it just shows 2.
Oh,
There, now it popped up.
I know, it's been a bit wonky. Yeah, okay, the audio's perfect. I'm not sure if you got the collaboratory link, Kazim. I'm sorry if I'm pronouncing that wrong, but you should definitely correct me. It's in the chat box as well. Okay.
Yeah, that's what we're going over right now.
Yeah. Did you request the audio? Because I don't know if I got the notification for that.
Kazim, did you click the little button at the top right, I think it was at? It should say request audio and video. There we go.
Okay.
All right, what's up? Sorry, I just joined. I came a little late. Sorry about that.
No, you're fine.
Yeah, don't worry about it.
All right.
I'm just glad another kid showed up besides me.
The only experience I have with vision detection is just I used OpenCV in the past, so I really enjoyed that. So I was hoping that maybe I can learn a little more advanced stuff in this session. So
yeah, definitely. If you actually open up the Jupyter Notebook,
Right. Yeah.
you can do save copy and drive and have your own copy in your drive to edit.
Yeah.
Okay. So sorry, Parker, if this is going to
No,
be
no.
very.
I don't mind you reviewing over everything.
Oh, great. Thank you.
That way he knows what we're talking about.
Yeah. So, I mean, it does sound like you have a fair share of knowledge in the. Oops, sorry, that was my notebook. So computer vision is, from an engineering point of view, it's a field that tries to understand and also model different mechanisms of the human visual system to try and analyze images for a certain purpose, or just for Instagram. So the first task is, if you do have an image that you want to play around with for this tutorial, then you're more than welcome to upload it, and just by clicking the play, or you can do Control Enter or Command Enter and then choose a file. And then I just stopped mine. But if you don't, well, I'm just loading anyways. So then you're just gonna load in image, and then sorry, I can wait for you. Have you loaded an image yet?
No, I have not. I was just looking at your screen.
Oh, sorry. Yeah, I mean, I can wait for you.
Yeah. Okay. 1 second. Oh, 1 second.
No worries.
All right. I think I got. Yeah, I got an image now.
Okay. Cool. So then go ahead and import the libraries in the next code box. So,
Okay.
and then.
Yep. That's done.
Okay. So then you're just going to edit this file name to your photo image file name.
Okay.
Okay.
1 second.
Okay, yeah, I did delete something on that one. I fixed it.
Okay. Was it the plot.im show? That one?
Yeah, that one. I deleted that one by accident.
Okay, no worries. I should have had it zoomed in way long ago.
Oh, you didn't know.
Hold on. It's saying that what you call as a type says this image, the image of data of D type object cannot be converted to float.
Oh, okay. It
I have a JPEG image though, so
okay. It might be okay. Do you have this? Do you have this ls cell box on top? Exclamation ls.
I don't have that. Do you want me to add that?
Okay. Yeah. Can you click on plus code? Um,
Yeah. I used Jupyter Notebook once before, so.
Okay. If you run that, it's going to list all the file names.
Right.
Do you?
Oh,
So if you can just copy and paste the file name into this portion.
yeah. In the quotes, it was .png, but the file was .jpeg. Okay, I got it now.
Okay.
So wait, are we learning about the filtering now, or?
Yeah, I'm just gonna quick use the channels around because OpenCV has a BGR channel instead of RGB. So if you just actually run img equals this portion right here, that's just going to flip the channels to what we're used to.
Oh, okay. So like in OpenTV you can convert like to different formats, right? You can convert to HSV and YCRCB. Can you do that with PyTorch or?
Um, I haven't actually dabbled on the file formatting changes in PyTorch. I would actually use OpenCV for that case. So just using multiple libraries for what they're optimized for. PyTorch, I would say, is more optimized in the learning aspect as well as the data loading and whatnot. And I would see OpenCV as more of image processing method tool. So in that case, I think it would. I think they're optimized for reading and writing different types of file formats.
Okay. Thanks.
Yeah. So I'm sure you're familiar with image smoothing, but the first image processing step or image processing method that we went over was image smoothing, and so the first one is the averaging, which is having we'll get into the filters and the kernels later, but it's having the same coefficients in all the elements in the matrix, and then just applying that across the image. So if you run that, it should give you a blurred image. And a different type of image smoothing is also called Gaussian filtering. There's also this one. So let me know if I'm going too fast too.
Yeah, I just have a question. What's the difference between the two? Because they look pretty similar to me.
Yeah, so I'll actually get into that.
Okay.
I'll actually get into that a little bit later with the image filtering. They do look pretty similar because the kernel widths are pretty similar in this case, but I think if you were to do let's see. So Gaussian filtering, it weighs less significance or importance in the far out neighborhoods of a pixel. So when it's trying to smooth, it looks only at the localized portion of the image rather than just blurring out the entire thing. So then when you come across maybe like an edge, if you're trying to smooth out a person's skin on an image, and you come close to the edge, it won't necessarily smooth out the edge of your face in the background, but it'll just limit it to the face. And that's like what the Gaussian filters are good for, is that it doesn't just do an overall just blurry image.
Okay.
Okay. Yeah.
And does the filtering just make it easier to process the image and process the pixel values?
Yeah. It's a quick computational efficient way. Because all it really is a series of multiplication, and it's a product sum. So we can actually go into that a little bit in a little bit. But before that, we have image thresholding, which is it's a simple concept of any value, pixel value that is greater or less than this gets flattened out to 0, and anything over it gets a 1 or something like that. And so you can have different ways of doing it. So the first thing we're going to do is load in the image as grayscale.
Yeah, I've actually used this before in OpenCV because it is a filter. So I use this like when I wanted to detect a ping pong ball on the screen, or when I wanted to work on one of my robotics competitions. I definitely used Thresh Binary.
Yeah, that's awesome. That's are you in high school or are you in college?
I'm a senior in high school. I used OpenCV in like my first robotics competitions. So yeah, that was basically, you just had to, like, take these frisbees, and it was like an autonomous robot you built, and then you had to detect the frisbees and then shoot them into this goal. So definitely, that's where
Wow,
I got some experience with OpenCV.
that's really cool. So you do like real-time image processing to get the roll?
Yeah, sometimes, but then most of the image processing is done before the match. So
Oh,
like
okay.
the objects can be put in like 5 different categories or 5 different places, and based on
Okay.
where the objects are, you have to do a certain task or shoot it into a certain goal or whatever it is, or a certain place. So so it's like you start the program, and then when they randomize the object, and then you can go when you click when the beeper sounds, then the robot goes. So it's stationary when you detect the image, but yeah.
That's really cool. Wow. Yeah, I didn't even do that in high Hey, you said cool, Parker. You wish you did something like that as well?
No, I was just saying lucky that he's a senior and not a junior.
Oh. No, time flies way too fast.
Especially now that people are inside all the time and not doing stuff.
Yeah, it must be so weird for you guys.
Not for me, because I'm inside all the time, so it doesn't matter to me.
Okay, we have one more person. I don't know if we have to start over.
Luckily, we haven't gone that far.
Yeah, that's true. I guess the Dankai. Okay. Well, while we're waiting for person, so the first portion, I guess day 1, covers image processing methods, OpenCV methods, as well as so this one's canny edge detection. So if we run this one, say if you change your parameter values to 50 and 100, so the lower threshold and upper threshold. So the way that this algorithm works, a canny edge detection, is that it first it filters out noise, and then it finds the intensity gradient, and so that's the change of intensity values across. So I was showing this with Parker, but if you see the intensity differences, the value differences between my hand and the black bookshelf, then it's a pretty high gradient change.
Oh, Yankai, you go to the top right where it shows the participants and the amount of people watching, and on the top right it should say request video and audio. Right under time left.
Is it? I do see you. I don't know if you're connected to a mic or.
Yeah, they probably have to go into their settings and do that. Maybe, I don't know.
Yeah.
Because I know I had to do it twice. Because in one we were doing a Zoom meeting, and then I had to do this one, so I had to do it twice.
Oh, okay.
I have a quick. Oh wait.
Sorry. Oh yeah. Sorry. Go ahead.
Quick question while you guys figure that. What does the aperture size variable do?
Oh, so aperture size is the size of the Sobel operator. And a Sobel operator is similar to a kernel or an image kernel right here. So it's a n by n operator, n by n matrix that you slide over the images to calculate whether there's a drastic change in the intensity values of the image, or whether there isn't. So that's you look at the change in intensity values across the aperture size of the operator, which is basically kind of like an aperture size of a camera lens or something. You kind of like limit it.
Okay. So like I changed the variable to 15, and then I crash. So like
oh, it's only between 3 and 7. Actually,
okay.
it limits, and it can only be odd numbers.
Okay, that makes sense.
Okay, some weird stuff happens in here.
Oh yeah, I'm keeping that down to 3.
And you can play around with the lower and upper threshold as well to try and get more edges or less edges.
So I would understand if there's like one threshold, like if the contrast gradient was greater than a certain value, but why is there 2 thresholds?
Yeah, that's so it's actually more of it's here. Let me it's a little bit more complicated in the sense that the lower and upper thresholds aren't necessarily just intensity values, but it's more of it's his hysteresis thresholding. It's I can actually send you a more in-depth explanation on it. Probably much better than what I say. So that's the documentation for the canny edge detection implementation in OpenCV. And
okay, awesome.
Yeah, so you're more than welcome to read that, but I think it goes into too like a detail that we're probably not going to go into. But that's a great question.
All right, nice. Okay.
And guys having technical issues.
Oh no.
Like they couldn't hear us at all. So.
Oh, really?
Yeah, it wasn't just their microphone and video; it was also their audio.
I wonder if it has something to do with the permissions or access issues.
I just think it could be the settings, maybe.
Yeah.
I don't know. Oh, okay, they can hear us now. Hey, Yankai.
Okay. Hi, Yankai.
So what I was saying earlier was go to the top right below where it says time left and it shows the participants and the amount of people watching. It should say request audio and video. So if you click that, then she'll give you permission.
Okay. Well, okay. I am. So in the meantime, Yankai, you can also look at this one.
Is image processing in OpenCV usually done in C++ or Python?
C++ and OpenCV, say CV2, which is the library that we imported into our Python notebook. That one is a wrapper for the OpenCV C++ version. So yeah, it's everything's implemented. Don't quote me, but most of the things are already implemented in C++ for this Python module. Just a lot faster. Yeah.
Right.
Okay, cool. Okay, that's good, Yankai. Well, let me know if you through the chat if you need me to slow down or wait. So we're gonna go on to morphological transformations, and this is these are some methods to erode an image or to dilate an image. Usually just a black and white image, in which case if you have a circle as an object in the image, it might be just a white circle, and that's the foreground object compared to the zero incomplete background. And so we can either make it smaller, erosion, or we can dilate it, which is dilation. And so we have something called a structuring element, which if the structuring element covers the foreground object entirely, for erosion, then it won't erode it. But for dilation, if it covers it, then it will dilate it. So based on what the structuring element looks like, you can kind of modify. Which structures in the image that you want to erode or dilate. And so we can look at the structuring element. We can actually change this to 5 by 5 because I think 30 by 30 was a bit of an overkill. That was too big. So if you just if you just run that, you'll see a 5 by 5 rectangle. So that's the structuring element we'll be going with. And then you can also in the next cell change this by 2 by 2, and run this cell, and you should have 2 images where you do the dilation first, and then the next image you erode by a 2 by 2. Did you get that working, Azim? Okay.
Yeah.
Cool. All right. So the next one is, it kind of goes back to the first image smoothing concept, and it's called image filtering. We've already done an example of this, so image smoothing. The way that you do it is you have an n by n matrix, or n by n by n matrix, whatever dimension that you're in, and you run this kernel through the image. And you multiply element-wise, and you sum it up. So then here, for example, you would multiply 1 times 1, and then 0 times 0, and 0 times 1. And you do this for every element in the kernel and the image that it overlaps, and you sum it up. Sum it up for this portion. So this equals 4. So this is, you can tell that this is a X pattern. It's a cross pattern because this is white, and we see this as white, and we see the 0 as black, and we run this through, then it'll pick up certain patterns that follow this pattern. So if the ones overlap, you'll end up with the highest value possible, or highest score possible, which is a 5. But this one's pretty close. We were just missing this upper corner here, so it becomes a 4. So image filters are used to pick up recognized patterns, but it's also used to for blurring as well. And the averaging kernel actually has all the same coefficients in the kernel. And so that is how an image filter works. And so if we look at this one, if we look at this one, then we can see that you're not limited to just one kernel pattern, but you can have multiple kernel patterns and be able to detect multiple different images, multiple different patterns. So that's a cool aspect. Like if you were to try and find a cross pattern and also a circular pattern, then you can run these filters through in all directions in the 2D image and be able to pick up those patterns and locate where the pattern is pattern happens the most in the picture.
Yeah, I think this is a little more confusing.
Okay. So
I just don't get the whole I and K thing.
okay. Which one? This one?
It says the I times K and stuff like that. I just don't get that kind of thing.
Okay. Am I hovering over it right now, or was it after?
Yeah.
Okay. So I is the input image, and K is the kernel. And so I asterisk K just means you filter the image I with the kernel K. So it's like a fancy way of saying you multiply each element by element by element, and then after you do that for all 9, you just plus everything up.
Oh, okay. So K is basically the whole pattern across the screen, and then whatever the image shows, then you just multiply them up. Okay, that makes more sense.
Yeah.
I'm confused on the how you get from like the math that is done to get from I to K, because it says that you multiply it by the top pixel.
It's because if you look at the K and then you look at the red square with the I, you can see at the bottom it says times 1 times 0 times 1 times 0 times 1 times 0. It's in the same pattern as K for whatever you're multiplying each one of those things by. The I is the actual image that's there. K is the pattern that it's giving out. So you use the pattern with the ones going across and the little zeros around them, and then you multiply that by the actual image itself, and it gives you 4. Because if you look at the red square, you can see 1 times 1, that equals 1. And then if you multiply all the rest, you can see that in that red square, if you multiply all that, it all adds up to 4.
That makes sense.
Yeah.
That's good.
Yeah, it's perfect. Yeah, so it's you product element wise, and then you sum it all up. And this is just an image saying that you have you can have multiple Ks.
Oh, okay.
Yeah. And so task 2 is we don't necessarily have to do this part because it looks like we are all different here. If you run this one, okay. It looks like my server is down. 1 second. Yeah. Okay.
Not found for me. Yeah.
Yeah, my web server is down right now. I don't know why. It's technical difficulties. But this was a portion where you, if it's back up later, then you can try it on your own as well. It's where you try to segment out. You want to segment out the top stoplight light and the bottom stoplight light, and then so you would just write your code here of which image processing steps and parameters that you would choose in order to just segment out the top and light bottoms. Top and bottom lights in the stoplight image. But I mean, I had a colleague do this too. He took 2 hours, so it's not as quick as I thought. So he's like,
Yeah.
huh?
Do you have like the answer on hand? I was just
Yeah,
curious.
I do have the answer. I do have the answer on hand, but I don't know why my image is not. I can't download the image because the web server is down. But let me see if I can just upload it here. No. Actually. Okay. I'll let you know when my server's back up, but I'm trying to find the same image that couldn't get. Okay, sorry. So
So
let's
servers are down on whatever that is.
yeah, my for some reason my web server is down and you can't download any of the images, which is perfect.
On the day you need it.
I know, right? But yeah, you can try that on your own. I do have an answer key for this. And so and then these are, so now we're coming to neural networks, which is a subcategory of machine learning or deep learning. And deep learning is a subcategory of machine learning. And these are actually the slides from one of my classes that I took. I currently go to UCLA. I'm a PhD student at UCLA.
Nice.
Thank you. And this is actually a graduate level course slide. So you guys are kind of skipping many levels here.
Yeah.
So neural networks are a series of equations that interact with one another to combine all of these equations to build a more complex and complicated function or equation. So the reason why learning is in the name in machine learning and deep learning and so on is that the parameters in these equations actually get modified with the data that the model sees. And so if we go into a bit more depth about it, you can ignore the bottom part. These are just noting what dimensions that the real numbers are in. But that's a topic for later. So
Wait,
you
I
have
have a question. So
yeah
PyTorch does calculates all the weights and does most of the math for you, right?
yeah.
So
So
yeah, okay, that's what.
sorry. Yeah, so basically PyTorch is optimized to, it does really fast calculations of the derivatives of each of the little components in the equations. So it pre-calculates the derivatives and then you just shoot the number in and then outputs a parameter that you want. So it's very fast. But for this class, you actually don't use PyTorch, you do it all by hand using just Python. So, but it's just derivatives. So it's just really slow. That's the only thing. But yeah, it's not as, it's, I was gonna say it's fun, but it's calculating all that isn't really fun, but, but yeah, it's really interesting. So if you go to the next slide, this one's actually more informative. The W matrix here is a matrix with weights. And when I say matrix, it's basically like it looks like this. It's have you taken matrix math? It's like row times column. No, okay, that's fine.
I just did calculus too, but I haven't taken matrix. I did a little bit of some matrix stuff and algebra, but just very simple stuff.
Yeah, this is all you really need to know. So you so each line here is represented by an equation, and so this is the input. So wx and plus b is like an intercept in algebra, and then h is the output, and then you plug in the output of the first equation into the second equation, and then you get the output of that one. So it's basically you take the output of the first equation and you put it in the next equation, and so it's like it's net, like it's does that kind of make sense?
You're talking about the layers, right?
Yeah, the layers. Yeah.
Yeah. So you have a hidden input layer, and then basically you go through the weights, and then you put the output values of the inner layer into the second part of the neural network, and then it creates the output layer, right?
Yeah. Does that make sense to you, Parker?
I think this kind of stuff is beyond me, honestly.
No, it's like no. Okay, so if you say like, okay, if you say 3 plus 4 equals 7, then 3 plus 4. So then the 7 is what gets. So then it's
lagging out.
Huh?
I think I'm lagging out.
A
little bit choppy there, but I think you're back.
Oops, sorry.
I think the Wi-Fi is a little down. Maybe, I don't know. Oh. I think she got kicked out.
Oops. Okay. Sorry
Welcome
about that.
back.
I was connected on a VPN, and it just died on me. I forgot I was on a VPN.
Oh, okay.
Oops.
Well, your video quality is a little bit better now too.
Oh, really?
Yeah.
Okay, that's much better. Okay. Oh, dang it! I always make that mistake. I'm always stuck on a really slow VPN, and then just kind of
You got down to 2 bars and then it died on you.
yeah. What are you wondering about the number of layers, Yankai? Okay. Yeah, we can actually go into that.
Doesn't that just narrow down like your outputs, kind of like just narrow down like just like let's say if one of the
Is it
layers
like
is
a microscope where it has each individual like level of intensity or something?
It's kind of it's more like I'm trying to find a more analogous term for it. So say it's more like you start out with like a slab of meat, and then you cut it and you grind it and you do something to it until it's and you cook it until it's
That's
edible.
basically sand.
Like, yeah, or however you like your meat. I'm sure actually people don't want it ground it to sand, but
No.
so it basically
It just basically zooms in each individual pixel, maybe.
well, it's actually the opposite. It kind of zooms out. So the filter kernels, if it's a 3x3 filter kernel, then as you go deeper into the layers, then you actually encompass a larger region of the image because if you can see, if you see from this example, a 3x3 red box here is actually reduced down to a 1 number. And so you end up reducing the dimensions. So this is 7x7, and then this one's a 5x5 box. You see that? So then it actually reduces the size of the image. And so when this
I see what you mean now.
Yeah. And so when this goes through the through another layer with another kernel, then if it's a 3x3 kernel, then this kernel here, well, the 3x3 kernel, the output will actually be related to a bigger area of this one because you're encompassing this number, and this number, and this number. And each number already covers this red box. So in a sense, if you cover all 9 boxes here, then you're covering like 27 boxes here. So then each layer, it ends up zooming out, and you get a sense of the local pattern as well as the global pattern. So like it might be from it might actually, there's a cool image that came out in a paper. Okay, sorry for the lag. So if you click on the link, this is basically like the different filters. Oh, actually, maybe that's not what I was going for. but those are actual like filters, the image kernels that you can have when you're trying to detect different faces in an AI network. So yeah, so basically you can have like a deeper layer to have a bigger region of interest that you want to look at, or you can also have, you're basically putting in more equations that will help you that will increase the complexity of the equation as well. So I hope that kind of answers your question. Okay. So now this one has 2 layers, 2 hidden layers, or okay, 2 hidden layers and a 3 layer network, because you have hidden layer 1, hidden layer 2, and then the output layer. And the important thing about a neural network is that we can do you know what nonlinear functions are? It's say you have a line that has a slope of m. Does this sound familiar to you, Parker? Algebra in a way?
Yeah, it sounded familiar, so I just looked it up, and yeah, I know what it is.
Okay. So, like a parabolic, like a parabola or parabolic function where it's like a U-shaped is a nonlinear function. So you can have non-linearity in the equations to help model the input and the output relationship better. And what I mean by that is, like, say you have on the x-axis the like time point of like the different years, and then you have on the y-axis different prices for houses. And so like a general trend would be like up, because like as the years go on, you expect the house prices to go up in a normal neighborhood. But like you might have dips during the 2008 recession, and then maybe like dips during the pandemic, which is happening right now. So then you have
Here too.
Huh?
It's about to happen here too.
Oh, really?
Yeah, because Biden's going to be implementing something to where if you didn't pay your taxes or whatever, then you lose your house. So all these people who haven't done whatever they need to do, they're going to lose their houses, and there's going to be a bunch of houses on the market, and that's why we're moving.
Oh, wow. I had no idea. Wow.
Yeah.
I'm gonna have to look into that.
Yeah.
Sorry about that.
No, I know the housing market's been kind of crazy because I know a couple of people trying to move, and it's like insane.
Yeah, that's why, because if you don't get it out on the market now, then a bunch of houses are going to be up, and then the value of your house is going to go down because there's
My sister, she's moving, and she was trying to buy a house, and someone bought like a house 3 months ago, and then they didn't do any like renovations, and like houses are going up in value like 30,000, 40,000. It's like crazy.
Wow. That's crazy. Oh my gosh, I had no idea. Well, okay, sorry. That was tangent. Yeah, sorry. But like say if you go down a little bit in price and then come back up, and you have this like up and down, like smooth up and down ridges, then it's not necessarily a linear function because it's not a line. it's a nonlinear function, but you have to be able to describe that mathematically, and this is what helps you describe the nonlinear line. So that's like that's the gist. So well, okay, this might be a little bit too much. You can just look at, like, this is the type of a nonlinear function where you have a straight line until you hit 0 and then up. So because it's not a continuous straight line, if it just ended here, then this would be a linear function, this would be a linear function, but it's not. So that's an example of a nonlinear function. And then you can just ignore the derivative. And another nonlinear function is also a sigmoid function, which shapes like this. So that's another one. And have you ever heard of a cost function? Not.
I think so.
Okay. Yeah, so a cost function is a way to motivate your neural network to get better in accuracy or performance, or whatever you want your neural network to do well. That's one thing that you want to that a cost function basically helps motivate your neural network to get there, to perform better. And so so those are the critical components. And so for part 3, for the convolutional neural networks, which combines the neural networks with the convolutions, the image filters that we were talking about, it's basically the first few layers you do convolutions, and then and we actually just covered this already. So yeah, so this is basically an image kind of showing the integration of the convolutional layers with the neural networks. I think Yankai was wondering if there's anything people can do with the housing market. Sorry, it's off topic, but it seems so sad.
No, you can't really do anything unless you get the house on the market now and get it sold, because if you haven't met whatever requirements are needed, then I think basically the most blunt way of saying it is basically you're going to go homeless.
Wow.
Yeah, it's not fun, but I mean,
Biden's tax ban on real estate.
That's what Biden's going to be implementing, is if you don't pay whatever needs to be paid off, then you're going to lose your house.
I haven't heard it in relation to the presidency, but I know that what I was referring to was that the housing market is just really like hot right now. Like everyone is trying to sell their house like right now. I don't know why, but
Yeah, a couple years ago, the housing market kind of dipped down, and so many houses went on the market because of, I don't know,
foreclosures.
Foreclosures. And I think that's the word of what's going to happen soon again, is something's going to be implemented, and then a bunch of foreclosures are going to happen. Unless people pay off whatever needs to be paid off. I don't know what it is, but whatever, if they don't do it in time, then they'll end up losing their house. It's sad.
That's really sad. I'm looking at it right now.
I don't know much detail, but so what my mom has been telling us a lot, because that's the whole reason why we're moving, is because we want to already move to a place where we feel like we can get away, because we live in a town with a population of over 10,000. So we're going to be moving to a place that has a population of 200 now. When we get there, it's going to make it a population of 203. But yeah, it's just Yeah, I'm gonna like it there anyways because I don't like being here anyways because there's too many people.
Oh, I mean, well, I live in LA and there are way, way too many people here. I think I would, yeah, I would, and the housing prices are ridiculous. It's like a 2-bedroom house. When I was walking around here, I looked up the price and it's 4.5 million. Like it's just, I don't, it's obscene. Um,
Yeah.
yeah, I've been planning on like building my own little tiny house in the forest. I've been actually looking at like a lot of YouTube tutorials. I just want to get away.
That's basically what we're going to. It's just more of a country place because where we live now, right here, it used to be country, but then the head of whoever wanted to have more businesses and such, so it's become less country and more business wise.
Mm,
Before they added in a bunch of fast food places, it was a bunch of gas stations. So great civilization right there.
wow. I guess it's like a town to stop by to fill in gas. No.
Yeah, I mean, the people in this town have no idea what they're doing, and uh, so Anna, they have like a water tower where they have lights coming up and whatever for their water tower. Well, ours it has like it used to have LED lights going all the way around it at the top, but then they put the lights at the bottom now, so you can't even see what the mascot logo is anymore at night because the lights just covered up with the shade.
Oh, that's so sad.
Yeah.
Well, okay, sorry. Back to
That was a tangent.
yeah, another tangent. So okay, we can just actually skip over these ones because I think they go on a little bit too much in depth for now. But um, other hyperparameters are learning rate, which is how fast you want to, or how big of a step you want to take every time you want to correct your model. So if you correct it a little bit at a time, of course, it'll take a longer time to reach the accuracy that you want. But if you take too big of a step, and you might overshoot it, and you might end up not you like if you actually needed to only change the price by $20, but then you said, okay, only change it at $40 at a time, then it's going to overshoot it, and it's never going to have those have a model that's able to, or have an equation that's accurate. And there's also epochs, which is the number of iterations that your model goes through during the training to see like if you train with more epochs, it gives the neural network more chances to learn the optimal parameters. But you might end up training it for so long that it might be like 2 weeks, and it might be the same. It might be at the same like accuracy than if you just trained it for like 2 days. So it really depends. It's kind of like a trade-off of like how much time do you want to spend on it, also to how much accuracy do you want. And so we're going to actually look at the MNIST data set. If you just want to run this portion. Okay, so the weird thing is, I don't know why a bunch of people's web servers are down today, but this web server is down too. So if you can just change, we're gonna actually look at Fashion MNIST, which is a collection of images of clothing in black and white. So if you just change the MNIST to Fashion MNIST, and it should start downloading. And then to view the images, you can just run this portion and we get a picture of a shoe. Exciting.
Change that fashion MNIST in the URL or in the variables?
Oh, just in after data sets, put fashion MNIST here.
Okay.
Because the MNIST data set is the web server is down. Did that work for you guys?
It's downloading them off, just
Yeah, it was
slow.
Okay. Okay.
So
I got
are we
a
just downloading the data set here? We're not doing any neural networks or training, or are we training?
Oh, we're gonna train, but we're just downloading the data set in this box, and then we're going to look at the images in the next box, in the next cell, and then we will go over the template 2D neural network in the next cell, which uses PyTorch. So yeah, just let me know when you're ready for the neural network portion.
Yeah, I'm ready. But one thing I just want to let you know in advance. I tried doing my own neural network not my own, but like following a tutorial.
Uh-huh.
And it was just like really a little overwhelming, I guess you could say, with PyTorch. So you might have to go a little bit slower. So I apologize.
Yeah, no, of course. Yankai, are you? I'm guessing you're at this stage now. Okay, so I'm not too sure how familiar you are with object-oriented programming, OOP. But we're making a class. So I'm not sure if, okay. So
I've been doing object-oriented programming for like a couple of years now, so I'm pretty familiar with that.
Okay.
But I'm just like with the neural network and the training and getting the not getting the weights, but just training it and the data set and stuff like that, the processing. That's when I have trouble using PyTorch, just figuring out how it works, kind of.
Yeah. So we have the initial settings here, like the number of channels, the number of filters we want to use, and the filter width or the kernel width, and the number of classes. In which case, this also has 10 classes. So this is 9, but so you can structure it like this, where you call nn.sequential, meaning that you want, this is basically a dictionary that is in a sequence, and the order matters. And so you have, for the first module, you have a 2D convolution, and then this is a batch normalization I put in there because it usually helps the learning better. But batch normalization is basically when you kind of it's when you normalize the data so it's not going wonky. So it's like a little miscellaneous step that I added in. I
That's
didn't
like
go
this
over.
the statistics normalization, right?
Yeah.
Oh yeah, I know what that is. Okay.
Okay. And then you have the nonlinear function value here. So that's the first layer that I've put on here. And then
I'm a little confused about the sequential and the convolution. So,
uh-huh.
I mean, I know like a dictionary data type, but I'm just confused. Like, can you explain a little bit more what exactly those functions do and why we need them?
For the sequential or the convolution?
Both.
Okay. So convolution is so these functions where it's like com2d, batch norm 2d, and value, they can they're basically individual functions and equations within themselves. But what the sequential does is it puts them in a series. So it's saying do the com2d first, do the batch norm 2d second, and then do the value. So it kind of modularizes all three into one function. And
That makes
so,
sense.
yeah, so the 2D convolution is basically what we showed up here, like this portion. And so that's what it's calling for. And then now we have our first hidden layer.
Wait. Oh, sorry, hold on. Your screen froze. I couldn't see what you were referring to with the
Sorry.
convolution.
The convolutional layers are this one.
Oh, so it just trains the data and finds the input layers, or?
Conv2D, it actually calculates the sorry, so far up. It calculates these numbers using these kernels.
Oh, okay, yeah.
Yeah, so that's the 2D convolution.
And then what about the inputs?
The input is the the picture of the shoe that I have on my, and yours might be different because it's randomized, but mine's a picture of the shoe. That's what the input layer is reading in. And so the picture of the shoe has, because it's in a grayscale format, it's one channel, so that's why I only have one. And then for number of filters, I have it as 5, but I think yours might be 40 or something like that. And then for the filter width, it's the width of the kernel. And then stride is when you're running it through, you can actually skip pixels and say, like, instead of going each pixel by pixel when you're doing the kernel, you can just do like every 5 if you want to.
So that makes the processing faster?
It does, but you lose information. That's the only downside. Yeah.
Makes sense.
And then you have, so that's from this step, you will output some value, and then this is basically the same exact function, except it's using different parameters. So you have the different parameter setting here. And then, okay, I put a third layer in, apparently. And then, so usually before the output layer, what we tend to do is we tend to squeeze these 2D images into a long array or a long vector. And then we do, we feed it in through an output function, usually like a sigmoid or softmax function, to be able to get the output score. So that's what we do here. And this is a linear function, which is not a 2D convolution, but it's actually a fully connected layer, which basically looks like this. So
the linear regression?
Yeah. So then it's like 2D convolution, 2D convolution, 2D convolution, and then you get the linear right here. So then that's what people usually go with. You try to squeeze everything into like one column. And then that's how you get the scores. And so the actual training is in the forward module, and you input your X, and then you get the output from that first input layer, and then you put the output from the first input layer to the second, and then so it's like kind of wrapping, and then you squeeze it into one column, and then you get the output layer. And so that's just the neural network. It's okay if you don't fully understand this, because everything's all written out and we can just run it. So we'll just run this here. You can actually comment this out because I think I got the right dimensions. Okay, so this is where the magic happens. So this is where you actually go train. Sorry, do you guys need to go? It's 6 o'clock. Well, it's 6 p.m. here, but it's 8, I guess, in your time or whatever. We can continue this tomorrow if you have to leave.
I'm good, but I mean, if you had to leave, obviously that would make sense. But I could stay for 30 more minutes. I have a calc test tomorrow, but I can stay for 30 minutes.
Okay. Yeah, I can do 30 minutes, but you guys are more than welcome to stay or leave. But so, did that make sense to you, Kazim?
Yeah.
Okay.
Yeah, I think that makes. So basically, what this is doing is just creating the weights for the input layers.
Yeah.
So when we do the magic, as you say, we're using the weights that we calculated or that PyTorch calculated, and we're just putting the inputs, and it's calculating using the neural network to.
Yeah.
Okay.
Yeah. So this is where we build the neural network, and this is where we put the input and we train it. And so, so this one it's a bit hefty. I'm not actually gonna go into it in too much detail, but so I have a function for training, and I also have a function for validating. And so validation is when you train on a data set and you want to see how well it performs on the data set that it hasn't looked at yet, then that's validation is usually the step where you kind of test how well your model does on an unseen data. So you start a for loop here. So you have a for loop here for the number of epochs or the iterations that you want, and then these are values I keep track of because it shows you the accuracy for each for each iteration, and so it goes through like small batches of data. So since you set the self.model here with the model from this cell, you assign it, you get the output, which gives you the probability of whether the picture is a shoe or a shirt or something like that. And then you calculate the loss using the cost function. And then this is where you actually calculate all the parameters and the derivatives. And then you step forward. These are just things that I calculate the accuracy of the training. And then the validation portion is exactly the same, but you want to make sure that you set the model as .eval so that you don't actually modify any of the parameters in the model. And then I do torch no grad, so that's saying that you don't have to waste time computing the derivatives of all the components in the equations. And so this is the same portion where I just calculate the accuracies, how many you get correct and how many you get wrong and stuff like that. And then I just and then I just print it out. So that brings us to the actual functional script that runs the model. And if you just click, or if you run the model, it's taking a while. Okay, so on my screen, you can see that in the first batch, I'm getting 60% accuracy, which isn't the best, but you can see that it'll start going up.
Wait, so is there a reason why it does go up? Is it because just the input data in the beginning is just bad, or what?
Oh, it's because when you actually take the derivative of the, so you're calculating the error that you're making in your training data set, and then you're using that error to fix the parameters in your neural network. So you actually take that error value, and then you go back to your model and you tweak it with that error value. So for each, actually for each batch, you actually correct your parameters. And that's why it should go up, because you're always trying to correct it.
That makes sense, but I mean, if you know there's an error, how would you know? How would you know how to correct the parameters without just like you could retrain the data, but wouldn't that just output the same thing? Like, how would you know what to adjust and how to adjust and why the model isn't working?
Yeah. So, so the way that you do it is, so if you have, I'm trying to think, so say you have a cost function where you compare the mean squared error values, meaning you're trying to see how similar two images are, and you overlap them, and or if you are trying to figure out the difference between two images, then if there's no difference, then the error should be 0 if you take the difference of the two images. But if there is some error, then if the images are slightly different, then you're going to have a positive value, maybe 5 or something like that. Because say pixel value of 1, a pixel value of 1 in a different image, if you take the difference, then it's 0. But if it has a pixel value of 0 and a pixel value of 1, then you're going to get a pixel value difference of 1. So that's like one way to tell that there's an error. So then you take the 1 from that cost function, and you actually go back and you plug it into the derivative of each equation, because you want to shift the parameters back in that equation the same amount that is equal to 1.
Oh, okay.
Yeah. But I can also I can actually go more in depth of the back propagation, which is a significant portion. I think it's a pretty tough concept. I would think for boot camp. But
Yeah,
yeah,
that makes sense.
but that's a really good question. Yeah.
Where is the back propagation done in the function in the code?
Yeah, it's actually done in so the back propagation, so the gradients are calculated here, or the derivatives are calculated here, and then the back propagation of actually altering the parameters according to the error that you get is here.
Oh, okay. All right.
And so right now I'm getting 78%, but the next step would be, well, the next task for you guys would be to modify the model above just this cell to try and achieve a better accuracy than what you're getting previously. But I think with that, we can start that tomorrow, actually.
Okay.
Yeah.
Yeah. All right.
All right. Thank
Alright.
you.
I had one quick question.
Yeah, sure.
So I noticed that your PhD was in like bioengineering and you're mostly doing like neural networks and stuff like that.
Mm-hmm.
So are you just in this field of like image processing just because you're like you're learning or planning on going into the field of like just like image processing in the medical field, like like in radiology and stuff like that?
Yeah. That's exactly what I'm doing right now. I am in the radiology, and I'm in the radiology department, looking at the I look at infant brain MRI images specifically, and I do AI algorithm development to segment out different regions of the brain, and that I've always been really fascinated by the brain and intelligence, as well as artificial intelligence. So I kind of wanted to bridge the gap, and I ended up doing computer vision AI, but I think something even more interesting would be neural computation AI, where you actually try to model human general intelligence. And that would be kind of similar to like what Siri is doing. Well, I mean, what Siri is, or like AlphaGo, and there are different avenues. But I think once I graduate, I think I want to go more in that, where it's modeling human intelligence rather than modeling the human visual system, which is this right now, which is fascinating, because you're still like, there are a lot of analogous structures between this neural network and how your brain actually works at the neuronal level for human visual system. But it would be more interesting if I can try to model like how a human thinks and how they are able to make decisions.
Yeah. Yeah, it sounds very interesting. Sounds like you could be also in school for a while.
What are your goals?
Oh, I'm doing a bachelor's in computer science.
Nice.
But I don't know what subfield to go to. I'm thinking about going into robotics, but I might have to get to a master's for that, and you also have to go to a pretty good school, like usually like an Ivy League, and I'm just not
No,
sure.
no,
Yeah,
I don't
yeah, I mean, yeah,
like
not all the time.
what like half the people I met from UCLA masters, like engineering, like electrical engineering, or I think aerospace engineering. Oh my gosh, Yankai is also a bioengineering major. Are you in college? Oh,
So
nice.
did they so they teach you PyTorch in college, or do you do everything from scratch when you work on your stuff or what?
They don't necessarily teach you. They just kind of like throw you under the water. They say like they kind of give you a template script like this, and then they say like you modify it, and then through trial and error you learn. And so it's. But I was saying half of the master's students, or a big portion of them, came from like public universities or just any university. I feel like. So I really like learning. There are definitely upsides and downsides to, because I did my master's as well in bioengineering, and then I'm in my 4th year for PhD. So it's a lot of schooling. It's not it's not definitely not for everyone.
Yeah, for sure.
But yeah.
Yeah. Okay. Yeah. So they just throw it at you and like you kind of like self-teach yourself, kind of.
Yeah. But I think that's how. Well, I think you would have to have some knowledge of programming before you take it. It is a prerequisite. But like I knew I learned C++ before I learned Python, so that did translate pretty well. But I don't quite know if like, yeah, I just don't really know how it would pan out if you had like no knowledge of programming. Then you might struggle, but you'll still get through it.
I mean I have quite a bit of programming
Yeah, it
since like
looks like it.
freshman year. Like yeah, so I know I'm very fluent in Java and C++ and even Python, but it's a little bit overwhelming, especially the math side effect. I mean I'm taking calculus too, so I do understand a lot of it, but it's also like I understand it, but there would be like no way for me to write the stuff by myself.
Yeah. No,
Yeah.
I mean, this is very this is actually pretty challenging for like even graduate students. So like we had like 4 lectures on just the math side, like the back propagation and derivatives aspect of it. But I think it's honestly such a fascinating area, and you guys are getting like such a head start in it. It's pretty amazing because I didn't even learn. I didn't really I didn't really get into AI until like 3 years ago, something. And that was like my first year in PhD. So, but yeah, I don't know where I was going with that. But Yankai, where, which, where are you? Are you in the U.S.? Oh, you're in Boston. Wow. Okay. So it must be like, is it 9 p.m. over there? Oh, okay. Wow. Yeah, do you have any more questions before?
I think that's it. Thank you for having this boot camp. It was definitely really helpful and informative for sure.
Yeah,
Very interesting too. So yeah, thank
thank
you.
you.
I'll try to make. I'll yeah. I should be also here tomorrow. Hopefully. Yeah.
Okay. Yeah, great. Thank you. Bye, Ankai. Bye, Kazim.
Bye. Thank you.